Okay, welcome back. And now that we have an understanding of the random variables, we know that they have to be numerical, and we have a sense of what a probability distribution has in it. What are those requirements? Now, the first one says that the random variable is numerical. Now, we already said before that a random variable has to be numerical, but this is just a reaffirmation of that. So there is a numerical, not categorical random variable x, and its number of values are associated with corresponding probabilities. Okay, so that one should be a pretty easy one to confirm. The second one, though, is a little bit more involved. So remember that funky symbol is our symbol for summation. So we want to add stuff up. So they want to add the probabilities and have it equal 1. So where x assumes all possible values. So the sum of all probabilities is 1, but sums such as 0.999 or 1.001 are acceptable when due to rounding errors. Now, that goes back to that 0 plus. So if there's a 0 plus in there, that's going to throw it off a little bit, but it's okay. So we do have a little bit of flexibility in that sum equaling 1. Now, you can't be too far away from either of these two possibilities, but if you're pretty close, if you're 0.99 or 1.01, if you're only 2 decimal points out, that would be acceptable as well. So we're going to see an example where it's blatantly not going to work. So that's the next one. That's the important one. The third one is also kind of a pretty straightforward statement. So this one says that 0 is less than or equal to p of x is less than or equal to 1 for every individual value of x. That is, each probability value must be between 0 and 1 inclusive. So inclusive means including. So that means 0 could be in there, 1 could be in there. So inclusive means including. So like I said, these first and third conditions are pretty straightforward. The second one, you actually got to do a little bit of math. But that's it. So if we're asked to determine whether or not we have a probability distribution, let's go through the steps. So number 1, is the random variable numerical? That's a big yes. They are, all those x's are numbers. So we're good. Number 2, the sum of p of x is equal to 1. Well, let's get the calculator out just to make sure. So we got 0.125 plus 0.375 plus 0.375 plus 0.125 equals, ta-da, we do get 1. So that's another yes. And then the third condition, so 0 is less than or equal to p of x is less than or equal to 1 for all x. Well, we can look at that pretty quickly and see that none of them are negative, none of them are bigger than 1, so we're good. So that's a yes as well. So table is a probability distribution. So that is, it's pretty quick, right? Let's do it one more time just to see it in action again. So number 1, I'll write it over on the side here. So the 1 was the random variable. That's a yes. We can see that. Number 2, sum. Well, we got to add them up. Let's see. 0.051 plus 0.141 plus 0.274 plus 0.331 plus 0.187 equals, uh-oh, where's my button? Well, you can see that's not close enough. That's a no. So the sum equals 0.984. So it's not equal to 1. Now the third one, which is 0 is less than p of x, less than or equal to 1, that's a yes. But if 1 fails, it completely fails. So in this case, the table is not a probability distribution. So it was close. You know, it had 2 of the 3 conditions met, but that second one actually is the one that's going to be the killer. So keep an eye out for that one. Be just very careful when you add that up. But you do have to indicate that all 3 conditions are met, all 3 requirements. So, all right. So now that we have a probability distribution and we know when we have one, what can we do with it? Well, I'm glad you asked. We can do means and standard deviations. Now, the formulas look messy. It's got those summations in there. So now remember, the variance is not going to be a critical thing, because if you know how to find standard deviation, you can find the variance. So we're really just going to focus on the mean and the standard deviation. So let's take a look at the mean. So we need to add something up. But remember back in the frequency distributions, when we had f's and x's and we had f times x and all those different things at the top of those columns in our table, a lot of those things we just added up. It's the same thing here. So this x times p of x is essentially a title in your table. So they're going to want you to add up that column with this title. And it turns out it's the very first one. The very first title is x times p of x in your table. So we're going to be able to do that pretty quickly. All right. So let's take a look at the standard deviation one. Again, a lot of stuff going on. We got the square root, which is pretty indicative of standard deviation. So don't forget that square root. But we got another sum. And now we got an x squared times p of x in the brackets. So this is going to be another title in your table. And then look at the other interesting thing. They have the mu in there. They have the mean. So you're going to need the mean in order to find the standard deviation. So very critical. So let's take a look at our table or our problem. It says find the mean and standard deviation. So we got 3 males with an X-linked genetic disorder have 1 child each. The random variable is the number of children among 3 who inherit the X-linked genetic disorder. So we're talking about children in this problem. All right, so X is referring to children. All right. So we've already identified the first title. So the second one, if we're going to try to get to standard deviation, we need an x squared. So that's actually the third title. And then the fourth title is our x squared times p of x. So now we got to fill in the table. So we got to multiply. So 0 times that is going to be 0. 1 times that is 0.315. 2 times that is 0.59. 3 times that is 0.615. So not anything too drastic, just multiply straight across. X squared, well, we know what x is, so we're just squaring all of those individual values. So 0 times 0, 1 times 1, 2 times 2, 3 times 3. And that gives us those. And now the last one, be careful. We want to multiply these 2 columns together. So 0 times that is 0. 1 times that is 0.315. 4 times that is going to be 1.18. And 9 times that is going to be 1.845. So pretty quick. Now, again, use your calculator to confirm those values, but that should be correct. So that's the first thing. Get your table completely filled in, and now we can start finding our different pieces. So our mean, remember, let me scroll down just a little bit. We have to add up that one column. So we're just adding this column up. And if we do that, we're going to get a 1.52. So the mean is going to be 1.52. Yeah, I'm waiting for you. 1.52 children. So now we need those units. So 1.52 children. And now to find the standard deviation, there's a little bit more to it. So we still got to add up that column with x squared times p of x, so we need to add up this last one. And if we add that up, I believe we get 3.34. But let me double check. So we got 1, 2, 3, so that's 12, 13, and I think we got it correct. So 3.34. So now let's just put everything in. So we got the standard deviation is equal to the square root of 3.34, so that first sum. So again, don't try to deconstruct this or anything. All that is a title. Don't try to think more of it. It's just a title. Minus 1.52 squared. Now, just follow the order of operations, and that'll break that down pretty quickly. So if we said 3.34 minus 1.52, but we got to square it. So I'm going to square it, and that gives me that. But now I got to put equals, because otherwise it won't know to do the subtraction. You're told it to, but you got to have it calculate it. So hit equals, and now that's the result. So we want the square root of 1.0296, and if we square root it, 1.01469, blah, 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 blah. Okay, so now the million-dollar question. How many decimal places do we need? Well, remember the rule, the round-off rule from chapter 3. When we're finding means and standard deviations, what was the rule? You carry one extra decimal place than your data. So our data, remember, is just a number of children. That's our data. So there are no decimal points. So minimally, we should have one decimal point. Now, like I've always said, you can always carry more decimal points, and that's fine, but do not carry less. So in this case, since we got 2 decimal points in our mean, let's use 2 decimal points in our standard deviation. So if we round that properly, we would get 1.01 children. Okay, so that is kind of how this is going to go. I'm going to actually save this next one for the next video because it's linked to the problem after it. So we'll see you in the next video.